Hello, Team Bio. This is Miss Luck. Today, I am going to go and talk about aerobic versus anaerobic respiration. It's objectives 11 and 12. By now, you should have read your packet on making ATP, and I'm going to kind of review and go over that with you right now. So we've spent a lot of time talking about glucose, and with the presence of oxygen, we get carbon dioxide, water, and ATP produced as a waste product. And really the big takeaways are that glucose molecules are transferred into molecules of ATP that are used by our cells for energy. So what happens when you feel like this? I bet on your first day of practice or hockey practice or your basketball practice, you've had all kinds of energy at the beginning. And by the end, you're feeling pretty wiped out. You've got some heavy breathing. You don't quite have as much oxygen. Well, that's what we're going to go over today. Let's remember the importance of oxygen and where it's needed is we need that for cellular respiration. But at a cellular level, we really need it in order to make water. That's where we get H2O in our water molecule. And I'm talking about the mitochondria level. So inside your cells, that's why we need oxygen. It's called aerobic respiration because we are right now talking about the inside of the mitochondria. I'm not going to go into a lot of details about that, but that is why oxygen is so important. So here we have this formula again with oxygen needed. We call it aerobic respiration. And specifically, it's in our mitochondria to produce ATP. So when oxygen is present, one glucose molecule produces 38 ATP. And here I'm in the way again. These are called cardio activities. When you have enough oxygen to continue to make ATP. You kind of get more bang for your glucose buck when oxygen is present. So if you've got one glucose molecule and 38 ATP produced, when there's the presence of oxygen, what happens when there isn't oxygen? What happens to your body when you can't take up enough oxygen to meet the demands? And I'm here talking about short sprints, maybe the 100-meter hurdles, maybe the 100 or 200-meter dash, where your body just can't get in enough oxygen. So when oxygen is not available and the mitochondria can't keep up with that ATP, it comes with a cost. That's why activities such as sprints and power cleans in the weightlifting, pretty good, huh? All can undergo what's called anaerobic respiration. With anaerobic respiration, we use that in short bursts and means without. Respiration means without oxygen. When oxygen is not present, we get one glucose molecule producing only 2 ATP. That's why you can't take the speed you would run a 100-meter dash for as long as a marathon, 26.2 miles. You just can't keep that speed up. You're only getting 2 molecules of ATP. So there's less ATP made when oxygen is not present. So let's look at those two types. We call that fermentation. It allows cells to produce that small amount of ATP without oxygen because glucose is only being broken down partially. So there's two types of fermentation that we're going to go over. And the first one is in animal cells, and it's called lactic acid. Notice in lactic acid, you take your 6 carbon molecules from glucose, 1, 2, 3, 4, 5, 6, and it is converted into 2, 3 carbon molecules of lactic acid, 1, 2, 3, 4, 5, 6. And here we have, if I get out of the way again, here we have our 2 molecules of ATP. So a little bit of ATP made from our glucose molecule when there is not oxygen present. We see lactic acid, again, when we have sore muscles. because lactic acid starts to build up. Eventually, your bloodstream has to send that blood to your liver to be broken down. We can maybe rub our legs out or take an ice bath to get that circulation going, or a foam roller to push that blood back through our system so it can get to the liver and be broken down. But look at this picture here. Here are your 6 glucose carbons, and here are your 1, 2, 3, 4, 5, 6, your carbon atoms in your lactic acid, and 2 molecules of ATP. Not very much. If there is yeast or bacteria, we now have our glucose molecule that can produce ethanol or alcoholic fermentation. So in this, my big takeaway is that we get some CO2. So glucose doesn't get broken down all the way, which is why there's less CO2 produced, and it creates bubbles. If you know the bubbles in beer, or no, you shouldn't know the bubbles in beer, but bubbles in beers and champagne, and actually the air bubbles in bread making. Those are all the CO2 from this alcoholic fermentation. So that's what we call the next type of anaerobic respiration, alcohol fermentation. It occurs again in the presence of yeast, hence the bread making, and bacteria as well, and it produces ethanol, carbon dioxide, and again, a little bit of ATP. You might be wondering, well, wait a minute. If we have bread and it's got alcohol, where that goes? It actually is baked off during the baking process. So don't worry about that. All right. Make this chart in your notebook. And let me move me. Make this chart in your notebook. You should be able to answer or fill out this table from the packet and from the information you were given in the screencast. And we will, you'll get to the answers eventually. Yes. And it can't stop me.
Are you going to stop it now? It's still going.
Miss Lively, you have to come help me. Help me stop this.